Polycet Aprjc 2022. Most important bits physics. Chapter is refraction of light at curved surfaces. So previous examination model questions, students, most important for practicing. A double convex lens of refractive index 1.5 with its two spherical surfaces of radius r1 30 cm, r2 45 cm kept in the medium air. So what is its focal length? So options are 15 cm, 37.5 cm, minus 8 cm, 36 cm. Lens is a given convex double convex lens, students. So now solution we explain now. It is a double convex lens. Principal axis, radius r1 and r2. r1 is given as 30 centimeter, r2 is given as 45 centimeter, and refractive index is a given 1.5. So solution, students, now refractive index n is 1.5. From sign convention, you know r1 is 30 centimeter. From sign convention rules, we want to take this one plus 30 centimeter. R2 is, from sign convention, it is 45 centimeter given. From sign convention rule, it is minus 45 centimeter. Now we want to find focal length. So you know the given quantities n, r1, r2, and quantity to be found is f. So relation among these is from lens maker's formula. So 1 by f is equals to n minus 1 of 1 by r1 minus 1 by r2 from lens maker's formula, students. So 1 by f is equals to, n value is a 1.5. So 1.5 minus 1 by r1. r1 means 30 minus r2 is minus 45. Then it will become, this is minus and minus, this minus and this minus will be plus 1 by 45, students. Now this implies 1 by f is equals to 1.5 minus 1, 0.5, and LCM, students, 45 and 30 LCM, 15 threes, 15 twos. So 15 threes 30, 45, sorry, 15 threes 45, 45 twos 90. So LCM is 90, students. So 90, then on cancellation it will become 3 and it will become 2. So 1 by f is equals to 0.5 means we can write as 1 by 2, and this is 5 by 90. 5 by 90. 0.5 is written as 1 by 2. That is 5 by 90 to 180. So cancellation, students, 5 ones, 5 threes, 15, 5 6. That is 1 by 36, students. We want f but not 1 by f. So reciprocal we are taking f by 1. That is, it will become 36 by 1, reversing. So therefore focal length is 36 centimeters, students. 36 centimeters. So f is 36 centimeters, students. So now you can see the options: 15 centimeter, 37.5, minus 8 centimeter, 18 centimeter, and 36. This is fourth one is the right answer, 36 centimeters. So now next question, students. Next questions, direct questions. Which of the following factors that the focal length of the lens depend? Size of the object, power of light source, wavelength of the light, and fourth one is surrounding medium. So surrounding medium can affect the focal length of the lens. That is, focal length of the lens depends on surrounding medium. Next one, third one students, a convex lens forms a virtual image. When the object is placed between focus and optic center, the size of the image as compared to the object. But you know convex lens can form both the real image and virtual image. But in the case of virtual image formed by the convex lens, image size is always larger than object size. That is why option 3, same size, smaller, larger, none of these. So larger is the option students. So in the case of convex lens virtual image, when the object is placed, convex lens forms virtual image when the object is placed between focus and optic center. The size of the image compared to size object is larger. It is a magnified image, larger image. Next to fourth one students, a lens having two spherical surfaces curved inwards. Curved inwards means this is students, it is curved inwards. So this lens is called biconcave lens students. This is called biconcave lens. It is called biconcave lens. So fourth one is the option for this students. So fifth one students, virtual erected image is formed when object is placed on the principal axis of convex lens. You know virtual erected image is formed when the object is placed between focal point and optic center. So this is. So next one students, an image is formed at a distance of 60 cm from the convex lens. When the object distance is 30 cm, then we want to find focal length. So here solution students, image distance is given 60 cm and object distance from sign convention it is minus 30 cm. From sign convention it is the negative and we want to find focal length. From lens formula students, 1 by f is equals to 1 by v minus 1 by u, that is 1 by 60 minus, and u is minus 30, this minus and this minus is plus 1 by 30. In LCM students for 60 and 30, 32, 31, so LCM is 60. So this implies 1 by f is equals to, this is a 60, and cancellation simplification here 1 and here 32's, that is 3 by 60. So this implies 1 by f is equals to 31 su, 30 20 su, so 1 by 20, but we want f not 1 by f, that is why reciprocals are taken. 1 by f is written as f by 1, then it will be 20 by 1, therefore f is 20 centimeter. So here the option students you can see most important bits. So in the previous examination asked bits. Next seventh one students, seventh one, pick the correct option from the reading the following statements. Option A, virtual image can be captured on the screen, real image can be captured on the screen. You know virtual image and real image. So the image which is visible directly called virtual image, the image which is not visible directly called real image. Generally virtual image can be formed on the screen, can be captured on the screen, but virtual image cannot be captured on the screen. That is why only real image can be captured on the screen is right. Only B is true. Next, paraxial rays students. Paraxial rays are just like the rays which are close to principal axis. The rays traveling very close to principal axis are paraxial rays. So the angle, they make angle 0 with principal axis. Next, concave lens always forms irrespective of object position. But you know convex lens can form both the real image and virtual image. In virtual image, in one case, remaining cases, real image. But concave lens, irrespective of object position, it always forms virtual erected image. But you know all virtual images are erected images, but real images are inverted images. This is the 9th one students. Next to 10th one. 10th one most important, if a convex lens has object distance and image distances are equal, say x. So u is equals to v is equals to x. Then we want to find focal length. But in which case object distance and image distances are equal in the case of convex lens? Consider it is a convex lens symbol and this is principal axis. Focal point f2, center of curvature c2, and focal point f1, center of curvature c1. When an object is placed at the center of curvature c2, then image is formed at the center. Image is formed at the center of curvature c1. So in this case, it is image distance v, and in this case it is object distance. So both are equal. This is also radius, this is also radius. That is u is equals to v is equals to radius. So here u is equals to v is equals to x means that is radius indirectly given x, students. U is equals to v is equals to x means from this figure you can understand u is equals to v is equals to r, because here to here this is distance, object distance. It is also radius, and here to here this is called image distance v. It is also equal to radius. That is why u is but here u is equals to v and it is equal to radius. Then what is the focal length? You know the relation between radius and focal length. Radius equal to 2 times the focal length, then focal length equal to half of the radius. So it is a given x, students. So x by 2. So option is x by 2. Next to question number 11, students. The size of the image formed by a convex lens is equal to that of size of the object. That is, image size and object size are equal when object is placed exactly at the center of curvature. When the object is placed, the image formed by a convex lens is equal to the size of the object. The size of image equal to size of object. 12th one, students. The lens which is thin at the middle and on both sides thicker. So you know convex lens is thick at the middle, but concave lens, that is biconcave lens, is thin. So this part is a very thin, and the middle it is a thinner, at the edges it is thicker. So here the question is asked, the lens which is thin at the middle, this is thinner, so this lens is called biconcave lens. Next, students, if 40 centimeter each is the object and image distance respectively for a convex lens, then focal length. Just now in the previous one, object distance is a given 40 centimeter, which is also equal to image distance. This is equal to radius, students. Then focal length is equals to r by 2. So then it is 40 by 2, that is 20 centimeter. In the previous problem we explained, when image and object distances are equal, it is equal to radius, then focal length is equals to half of the radius. Question number 14, students. A lens having two spherical surfaces curved inwards, students, like this. It is curved inwards, it is curved outwards. So this is a biconvex lens. Curved inwards means this is a biconcave lens. So option is biconcave lens. It is curved outwards, biconvex lens, it is curved inward. The question is curved inwards means this is. Next, students, refractive index is 2.8 N1 and refractive index N2 is 1.4. Then N12 we want to calculate. You know N12 is relative refractive index of N1 with respect to N2. So N1 by N2. N1 value is 2.8. N2 value is 1.4. Then it is equals to cancellation 2. So this is the option. That's all, students.